Here we're given the graph of a function y equals f of x, and we've been asked to sketch the graph of y equals f dash x. To do this, we note the nature of the gradients as we go towards the two important points where gradients are changing at negative 2, 16 and 2, minus 16. So I go towards an x-coordinate of negative 2, my graph is sloping up, so my gradient is positive. At the point negative 2, 16, my graph is changing from sloping up to sloping down, so at that point my graph must be flat, which gives me a gradient of 0. As I go away from negative 2, going towards 2, this region of the graph, the gradient is sloping down, so my gradient is negative. At the point 2 minus 16, my gradient changes from sloping down to sloping up, so my gradient must be flat or 0. So I go away from x equals 2, my graph is sloping up, so my gradient is positive. As f dash x is a formula for finding gradient, I've got to consider the gradient of my original graph and how it's changing when I sketch the derived function. And the two important points are when x equals negative 2 and x equals 2. Now in my original function, as I went towards negative 2, 16, x-coordinate of negative 2, my gradients were positive, so my f dash x values will all be positive going up to negative 2, or above the x-axis. As we go towards an x-coordinate of negative 2, they're getting to being a value of 0. So when my x-coordinate is negative 2, we must cross the x-axis. As I leave negative 2 and go towards 2, my gradient values are all negative, so that will make them all below the x-axis. However, they're trying to get back to 0, or crossing the x-axis, where my x-coordinate is 2. As I leave an x-coordinate of 2, my gradients are positive, so they will all be in the sketch of the derived function. The graph values will all be above the x-axis. And here we have a sketch of the derived function.